Okay, alright. Hi and welcome back to our educators. So untuk hari ni saya nak sambung dengan chapter 3, subtopic 3.2, heat of reaction. Okay, so for this subtopic saya rasa lebih kurang you akan ada dalam 8 video for only this subtopic sebab dia ada banyak learning standards that I have to cover up untuk you ni. Nampak tak this whole thing ni? Okay, I have to cover up lah. Okay. So tu benda pertama lah. Okay. And come, let's see what is heat of reaction. Okay, heat of reaction ada tak payah tulis lah. Okay, heat of reaction ni kat bawah ni ada. Okay, through precipitation process we got heat of precipitation. Through displacement process we got heat of displacement. And through neutralization process we got heat of neutralization. And through combustion process we got heat of combustion. Okay, kalau dalam bahasa Melayu, haba pemendakan terbentuk apabila proses dua garam larut kita gabungkan dia bentuk garam tak larut kan. Tu suatu proses. Displacement maksudnya penyesaran, okay? Penyesaran. And then neutralization, peneutralan. Combustion melibatkan pembakaran yang ada oksigen. So you have to understand these two usually jadi favorite untuk SPM. Memang macam every year, bukan every year lah, mostly lah, trial semua memang benda ni ada. Especially this neutralization, dia yang paling hot. Okay, so if orang tanya you what is heat of reaction, this should be your what do you call that, your answers lah. Ada 4 yang you belajar. Nanti belajar further ada lagi banyak lah. Okay, and then so your first learning standard is you have to determine heat of precipitation through activity. Next, displacement through activity. Okay, basically this 1, 2 and 3 ni dia berkaitan dengan paper 3. Okay, through activity means you kena buat conduct the experiment. Okay, so itulah biasanya neutralization lah, that's very famous. But remember, semua boleh ditanya untuk this one lah. Okay, then saya nak masuk sikit lah. The heat of reaction can be determined through experiments by establishing the temperature change when the reaction occurs. So the value of temperature change obtained is used to calculate heat of reaction. So maybe we will use MC theta, okay, equal to Q tu. Okay, adalah dia punya formula tu. Then ini just benda biasa sahaja, tak ada apa pun. Okay, and then unit. Okay, for this heat unit ni kan, we will use joule and kilojoule. Ada dua-dua. So dia akan berubah-ubah ikut kategori. So saya akan tunjuk bila akan ada kilojoule, bila akan ada joule when saya discuss the contoh for each one of the. Especially this precipitation ni memang ada banyak perubahan unit. Okay. Okay, next one. Okay, next one. Step 1, step 2 and step 3, step 4. Okay, ada 4 step kan. Okay, first step you have to determine the number of moles of the reactants and product form. Okay, you have to tengok lah soalan bagi information apa, berkaitan reactant ke product. So from there you boleh find number of moles, so go ahead first. And then step 2 baru you kira heat of change by using Q equal to MC theta. Okay, Q is heat change and then you have to calculate for 1 mole. Okay, 1 mole ni kena buat persamaan lah. We will use the chemical equation here. Okay, here is chemical equation. Ada chemical equation. And lastly, we have to state. Okay, ramai careless kat this process. Okay, when you state delta H sama dengan apa, you lupa mention benda ni. Tambah atau tolak, you tak mention. Ataupun kat belakang letak kilojoule sahaja. Oops, letak kilojoule sahaja. Per mole you tak letak. So salah, memang salah you tak letak. Okay, tak boleh. Kena letak the whole thing. This whole thing should be there. Tambah tolak ni optional lah. Sometimes tambah, sometimes tolak. So depends on the situation. Okay, and then next one, the number of moles and to the types of heat reactions as follows. Okay, kan kita cari number of moles kan. So the number of moles tu berubah-ubah ikut jenis tindak balas. If let's say it is a heat on precipitation, so the number of mole yang you cari tu mole of the precipitate. Faham tak? Maksudnya you buat eksperimen pemendakan, precipitation. So you are the information about the precipitate, so you find the number of mole. So that is the number of mole for the precipitate, it not for other things. Faham tak? Same goes for the displacement. Okay, the number of mole you find tu for the metal displacement. Faham? Sorry, for the metal displaced. Maksudnya which metal was displaced, that is the number of mole. Faham tak? And then mole of water. Okay, utilization special tau. You kira number of mole, what you get is the number of mole water formed. Okay, it's not something about acid or alkali. And the last one is fuel burn lah. Okay, actually this thing you memang tak faham sekarang. So what I want you to do, just baca dulu. Sebab benda ni you akan faham later once you dah once you dah masuk the further topic. Okay, once you dah masuk further topic. So as for now, you boleh baca je dahulu. So saya put a tick baca lah. Okay, and then most chemical reactions are carried out to determine heat of reaction involve aqueous solution. Some assumptions. Okay, kita ada buat assumption. The density of any aqueous solution, tak kisahlah tu whatever aqueous pun, it is equal to density of water. Faham tak? Okay, so kenapa kita ada guna density yang saya akan beritahu. So remember that whatever aqueous solution you have sodium chloride ke, sodium chloride ke, magnesium hydroxide ke, whatever it is, if it is a aqueous solution, dia punya density ketumpatan is 1 gram per centimeter cube. Dia punya density sama dengan density water. Faham? And next one, specific heat capacity untuk mana-mana aqueous solution sama dengan specific heat capacity of water, which is 4.2 joule per gram degree Celsius. Tu kedua. Dan lagi assumption seterusnya, no heat loss to the surrounding. Okay, maksudnya from this 4 heat yang kita belajarkan, precipitation, neutralization, displacement dan combustion kan. So tak ada heat yang pergi kepada persekitaran. The heat tu pergi kepada the apparatus. Maybe, faham tak? Heat yang dibebaskan oleh benda yang, contohlah you buat precipitation, benda tu bebaskan heat. So the heat is to the apparatus, not for the persekitaran. Why? We are not absorbing any heat from the apparatus. Faham tak? Ni another one. Okay, let's say lah the process tu, maybe the neutralization, let's say maybe the neutralization dia absorb heat, tapi dia bukan absorb heat from the apparatus, daripada surrounding. So benda ni actually is just a basic assumption je, nothing to do, just you nak tahu saja. Okay, you can ask me, benda ni akan ditanya ke? Okay, sehingga sekarang saya tak jumpa soalan berkaitan assumption ini either dalam paper 1, paper 2 atau paper 3 pun. Saya tak pernah jumpa lagi. So just baca sahaja, it's just like an introduction. Faham? So saya rasa tu saja untuk early introduction untuk this subtopic, this early page ni, dua page ini 120 dan 121 sampai atas ini is just what we want to highlight in this video is we got 4 type of heat of reaction and I want to highlight the process. Ini saja I want to highlight, and remember we are going to use unit kilojoule and kilojoule, mole dan juga joule. Ada 4 unit ni lah. Okay, so kalau you tulis delta H, always kilojoule per mole. Jangan you lepas per mole ni, you letak kilojoule saja, salah. Faham? Tu saya memang dah bagi tahu kat step 4 ni, so tu saya nak you take note. And other than that, I don't think so ada benda yang saya kena highlight. Assumption ni kita just bagi tahu supaya you tahu. So you have only 4 assumption. Ingat, density of aqueous solution is equal to the density of water, 1 gram per centimeter cube. And then second assumption is specific heat capacity for an aqueous solution is simply same with the specific heat capacity of a water, which is 4.2, the unit behind to joule per gram per degree Celsius. And then remember, no heat loss for the surrounding and no heat absorbed from the apparatus. Okay, ni the assumption. So if let's say lah tiba-tiba batch you ada satu soalan, state few assumptions that we do make before calculate the heat change in a process. So you can state any one of these. Faham tak? Macam saya, I usually would say this third one is easier. No heat is lost to surrounding and no heat absorbed from the apparatus from the experiment. Okay, dah settle. Tu saya sangat-sangat ingat lah. Ataupun you can say density. Density of aqueous solution is equal to density of water, and the specific heat capacity of aqueous solution is equal to the specific heat capacity of water. It's like water. Sebabnya aqueous solution tu dia macam water je. Tapi apa bezanya? Nanti saya akan terang dengan lagi di detail. But as for now lah, aqueous solution ni dia macam-macam dia bentuk tau. Maybe dia ada pepejal tu, dia campur dengan air jadi aqueous solution. Faham? It's simply like that. Okay, contoh lagi senang lah nak katakan. Okay, let's say you ada satu cup. Okay, anggaplah ni sebagai cup. Dalam mesti masuk garam. Lepas tu you dah buat air garam kan? You masuk air. So, it is an aqueous solution. NaCl aqueous solution. Okay, sodium chloride aqueous solution. If saya just letak garam dia, it's just NaCl solid. Faham? Dia macam tu je. Beza antara aqueous solution dengan solid. No further difference lah. Okay, so in next video, I want to teach about heat of precipitation, where I'm going to highlight about this thing and I'm going to explain about these calculations. Okay, to calculation ni separately, then only afterwards I akan buat laboratory activity 3B. Okay, so this is my plan. So saya akan upload video-video ni secepat yang mungkin. So you please continue watching and do let me know if you have any other questions. Okay, that's all. Bye bye.